Follow up with our race car data and talk about what's actually happening here with these transformations that we're doing. So this is my calculator. I already have plugged in all my X values, the pullback distances, my Y's, which were the recorded distance traveled. I have in my third column all of my X squared values, and I also have already plugged in the log of Y. So if you are looking at your notes, we have these three different plots we're supposed to make. The linear plot is what we've been doing with scatter plots, just X values, Y values. The next two use our X squared values and the log of Y. And to come up with the equation for these, we actually use the same system that we do with the linear plot. So I'm going to do my quadratic formula here first. So on my calculator, I would do statistics, stat calculations, and we still choose linear regression. So I choose linear regression, except this time my X variables are all the X squared values. And then for Y, I would still choose the Y output. And I get this, remember your calculator will kind of output all your data for you. So the quadratic plot here, my formula would be Y hat, remember these are predicted values, equals, my A value is the negative 2.562 plus 1.067x. Now what's different though is because it's X squared values, the X in my equation has to be X squared. And that's the only difference. So you kind of follow the rule of whatever values you're plugging in here. So I'm going to do this again on my calculator for the exponential data. I'm going to clear out so I don't get too crowded. Okay. So again, you just follow the coordinates that we're plugging in. Here it's X and log of Y. So I'm going to go to, again, statistics, stat calculations, and again, choose linear regression, even though we're using log. My X values will be all the original X's, but my Y list will be the log values. And again, here is our A and B outputs. So I have Y hat equals, my A value is 0.56 plus, we'll do 0.1519x. And the difference here, just like in quadratic, we changed it from X to X squared. Now we have to change from Y to log of Y. So this equation is actually log of Y hat equals, and then you can write the rest of your equation. And when you go to decide which equation is best, you have to make this into a Y equals equation. So right now we're graphing log of Y. So remember the inverse, we'll have to do 10 to the power of, and you plug this all in as your exponent. So let me show you on a graph what this all looks like. And you can kind of see, so here on my graph, I have all my X and Y values. This is the original pullback distances and the distance traveled of my cars. Then I have my three equations. The first one was my linear equation, then my quadratic, then my exponential. So what happens when you graph your linear, and you can see on my graph here, I am missing a lot of these points, right? So in orange, like these points are really far above. Down here, I missed all of these points. So linear might not be the best fit. And that's why we use these other functions. So now instead of linear, I might try my quadratic. And that looks a little better. I start hitting some of the points down here. I get really close up at the top. And my third choice was the exponential, which is now my green line. And that looks really good. So I get really close to those first 3 points. I hit one of these points and I come up and cross through the middle. So when it asks you which regression is the best choice, you have to decide, but think about things like your correlation values. think about things like the residual plot. So me comparing how far those points are away from each line, that's comparing the residuals. So those are some of the things you're going to be looking for. And then you have to decide which one you want to use to make your predictions for our race in class next week. All right, so I hope this helped a little bit with your equations, and let me know if you have any other questions.